Hello, this is Mr. Win, and I'm going to show you how to solve by calculator. Okay? This can actually be done at home through a website called desmos.com. So you actually don't need to be in class and use the inspires, right? So these I'm giving you a situation where it's pretty complicated, right? It says Mr. Win, like number 1, is going on a road trip, and the data in the table shows the relationship between speed and fuel economy for his car. And then it gives you a table. Now that table is nice, but it doesn't give you all the values, so you really don't know what's the best fuel economy. Okay, because if I read the equation, it's going to ask us. The data can be modeled by the quadratic function y equals negative 0.0072 x squared plus 0.565x plus 12.5, where x represents the speed in miles per hour, y represents the fuel economy in miles per gallon. Which speed rounded to the nearest whole number will give them the best fuel economy? So we are looking for the best, right? So if this is a quadratic, right, just think, if I drive, too slow, I'm not really using not using that much gas. I'm not really going that far, so I'm really not, getting much fuel economy. But if I drive too fast, right? So if I drive too slow, I'm not really using all of it. If I drive too fast, I'm burning gas way too quickly, and maybe I'm not using that fuel economy the car is, meant to be at, the best fuel economy. So it kind of makes it quadratic, all right? That equation, I'm going to put that in the calculator. So, or in this case, I'm going to put it into Desmos. So I'm just going to switch it over, right? So here's that equation. Okay, let's put that equation in. So here's Desmos, right? I'm just going to go here, put that whole equation in. So y equals, I mean, if you need to see it there, negative, that's going to be 0.0072 x squared, so x squared plus 0.565 x plus 12.5, press enter. Oh, not equal, sorry. Let's erase that. Equals, okay? And then it'll give you a nice graph, right? So if I look at it, here's my graph. Notice how I'm kind of zooming out, right? You do want to see the whole graph, so I'm just using my fingers to zoom this out, right? The nice thing about Desmos is if I click on that graph, it'll give you certain points. It gives you, like, say here, the y-intercept. It gives you the x-intercept, y-intercept, fuel the maximum, right? So if you click on the graph, it gives you those points. And if I click at the very top, right, it makes sense. That is going to be the best fuel economy. That's what's called your maximum point, okay? So we're going to use that point. So if I go back to my problem, oops, click that. I'm going to go back. Okay, remember that number, right? 39.236. I'm going to go over here, and which speed rounded to the nearest whole number will give them the best fuel economy? It's going to be 39.236. But it does say round to the nearest whole number. So in that case, it would be rounded down. It would be at 39. Okay? So number 2 is pretty much the same, It might ask for the maximum, whatever. Number 3 looks like it's asking for a 0 when it hits the ground. So if we had an equation, right, the point here, the one that just showed up is 0, right? That's where it hits the ground, and so on. Number 4 talks about Dak Prescott throwing a pass to Dez Bryant, but you got to account for the height. Okay, so the football is thrown at 2 meters high. Okay, so that means you don't want the 0, but you want where it can go 2 higher. So really, if you go to the graph when doing number 4, let's just say, let me look at that equation again. Okay, so if I put that equation in, all right, let's just give another equation here. Negative 5x squared plus 15x plus 2, right? There's your graph. You want to find, that's the ball being thrown in there. You want to find when it's 2. Well, if I click and hold down on your graph, you can kind of look for a point right here. You see, kind of look for a point. When does it equal 2? Well, the height has to be 2. So the y has to be 2. It's kind of parallel to it. So if I go over here, 2 would be at about 3, 2. See it there? You can kind of trace along this. So I can go get as close to 2 as possible. It'll actually be at 3. If it'll let me get there. See, 3, 2. So when he threw the ball, he's at 2 meters high. When Des catches the ball, it'd be 3 seconds later, 2 meters high as well. Okay? So you can trace. You can really look at any point you want. It doesn't have to be the x-intercept, maximum, all that. Okay? And look at these other problems. What if I give you a table? How do you find the quadratic function if I give you a table? Well, Desmos actually puts the table and graphs it for you as well. Or you can grab the linear regression, right? I'm going to show you how. So I'm going to click the plus sign, go to table, and let's put in our values. So -4. All right, let's get the next one, -3. And notice how it even fills it in for you. It starts noticing the pattern, right? 0, okay, and then go over here, 2, -4, -6, -4, and 2. All right, I have my table in there. And notice, I'm zooming out, it kind of gives you the points. You can kind of see it's a quadratic, right? Isn't it going down? But what is that equation? This is how you type it in. And this is pretty specific. You got to type in exactly how it is. So you want to type in y, but not just y1. All right, and then you want the little squiggly sign. It's called a tilde. So I'm going to go to the ABC, the keyboard, and down at the bottom, there's that tilde symbol, right? That's kind of approximating the equation. So we're not going to have y equals, but that's why you got to do y1 tilde, and then our equation, which was a, okay, and then it's going to be x squared. We're just putting in the standard equation. Oops, excuse me, x1 squared, almost forgot. x1 squared plus b, okay, x1 again, x1 squared, no, not squared, just x1. You want it exactly how it looks, and then plus c. So go into plus, go into our letters, c, and there we go. It actually gives you some information. So I'm going to put down the keyboard there. Right, it gives you the equation, the a, b, and c in your parameters. Okay, so that means our equation is just going to be the 2 goes where the a is, so 2x squared plus 8x plus c. That will be the equation for that first graph. Okay, and that's it. You can use Desmos. You don't have to use the TI Inspire. You can do this equation all through the calculator online.